In section 4.6a, we're going to be looking at graphene secant and cosecant functions. So these are still trig functions. So now we have two new parent functions, cosecant and secant. And so just like we saw with sine and cosine in 4.5, all right, A is going to be our amplitude. B is going to be our period. And when we're working in radians, we can calculate our new period by taking 2 pi divided by b. C is our phase shift. So that is left or right. Okay? And D is our vertical displacement or vertical translation. So that is up or down. Okay. Let's talk very briefly first about what cosecant is. So remember that cosecant is the same as 1 over the sine. Okay, so this is going to have some similarities to the sine graph in that we're going to have key points in the same places. All right, so I have nothing inside my function with x. There is no b value, all right, to affect the period. So our period is still 2 pi, okay? So what you want to do when you take these is you want to, 1, graph sine of x, because we're pretty familiar with that one by now, okay? But you want to do that one very lightly, okay? So a dashed line if you're working in pencil, okay? So sine starts at the origin, and then it's going to go have a maximum there, a 0, and then a minimum, and then be back to where I was. Okay, and then it will do the same thing. I'll have the same pattern on the left. Okay, and so I'm doing this in yellow, so it's visible. And I'm going to use it, but we don't want that to be in our final answer. So if you were doing this with a pencil, you'd erase it at the end. Okay, so the second thing you're going to do is you're going to draw your asymptotes, okay? Because this is 1 over the sine of x, every time the sine of x is 0, I have an undefined function, so that is where my vertical asymptotes in cosecant happen, okay? So that happens every time the sine of x goes through 0. So at 0 and then plus or minus multiples of pi. Okay, the next thing we're going to do is draw U-shapes. Okay, and we're going to start those where we have maximums or minimums. Okay, so if it was a maximum, it becomes a minimum, so my graph goes up like that. If it was a minimum, it becomes a maximum, so my graph goes like that. And then the same thing over here. Okay? And then because these go upwards past our edge, we're going to make sure we put arrows on all of them to denote that. We're going to follow a very similar process for graphing the secant of x, all right? But that is now 1 over cosine of x. So we're going to be using the cosine function to draw our asymptotes and our U-shapes, okay? So again, this is just the straight old plain vanilla secant function. There's been no transformation, so our period is 2 pi. All right, when I have cosine of x, I start at 1, and then I go down initially, and I will have either a maximum or minimum at every multiple of pi. Okay, so we're going to go put our key points in here. All right, now we're going to use those to draw our asymptote. So now every time the cosine of x was 0, we're going to get a vertical asymptote. Because now it is my secant that is undefined there. Okay, so now I can draw my U-shapes. So again, if it was a minimum, it becomes a maximum. And if it was a minimum, it becomes a maximum. Okay, now we know what those parent functions look like. Now we're going to go through our transformations. So in 3, we're graphing y equals 2 times the cosecant of x. And I know it helps me if I always put that cosecant is 1 over the sine of x, and that way I can remember which one, sine or cosine, I'm using to create my asymptotes in the first place. Okay, so before we start, we're going to figure out our period. All right, there is no b value, so our period is 2 pi. There is no phase shift because nothing is added inside the function or subtracted. There is nothing added at the end, so there is no vertical displacement. There is a vertical stretch of a factor of 2 because I have a out here, that's my amplitude, okay? And I don't have a reflection either, so there's no reflection because 2 is just a positive number, not negative, okay? So, again, I'm going to start with my parent function, except now I'm going to draw that with an amplitude of 2. Sine of x starts at 0, and then because we still have a phase of 2 pi, or sorry, a period of 2 pi, okay, I'm going to have zeros at multiples of pi, and then I go up first, but instead of going up to 1, I go up to 2, and then at 3 pi over 2, I go down to 2 instead of down to 1. Okay, and then the same pattern over here. Okay, so I'm going to use that, and I'm going to make some dashed lines for my parent function, including the transformation. Okay, remember our second step is to draw our vertical asymptotes, and those happen everywhere that sine of x is 0. And then I finally get to draw my graph that I'm going for, and I use my previous minimums to become maximums, and I use my previous maximums to become minimums. Okay, now we're going to look at a different transformation. Here, we're graphing y equals cosecant of 2x. So again, the one we're using to create our asymptotes is 1 over sine x. All right, and we're going to look at our transformations. Our period, now there is a b value, so it is 2 pi divided by b, which is 2, so our period is now just pi. We have no phase shift. We have no vertical displacement, and our vertical stretch is just our normal amplitude of 1. Okay, so we start with our sine function, and we're going to graph that, okay, but again, now we're going to make this with a period of pi. So when x is 0, we start at the origin, but now I'm going to end up having 2 zeros there, okay, and so I have to have a maximum in between there and a minimum here, and then I'm going to have a minimum and a 0 and a maximum and a 0, and that would continue on, but we're going to stop there just to show you how this works. Now we use those zeros to draw our vertical asymptotes, And you'll notice as you get more practiced at this, I've stopped sketching my sine graph or my cosine graph, and I just use those zeros and those key points to figure out what's going on with my secant or cosecant. Okay, I have my vertical asymptotes, and again, I use what was a minimum to become a local maximum, and what was a maximum to become a minimum, and so on and so forth. And again, this would repeat, all right, in both directions as a periodic function. Okay, for the next one, our function here now is secant, and so we're going to use 1 over cosine x to create our key points. All right, our period is 2 pi. There's no phase shift. There's no vertical displacement, but there is a vertical stretch. There's no reflection, but now my new amplitude is 1/2. So I'm going to use cosine, but with an amplitude of 1/2 to sketch my key points. All right, so cosine usually would start at 1, but because my amplitude is 1/2, it actually starts at 1/2 on the y-axis. Okay, my period is still 2 pi, so at 2 pi I'm back out here. Okay, halfway in between there I have a minimum at negative 1/2, and then my zeros happen halfway in between my maximums and minimums. Okay, and then again that pattern continues. Okay, so now, okay, I have zeros to draw my vertical asymptotes. And my local maximums now become local minimums and vice versa. Our next graph is going to be y equals the secant of 1/2 x. So remember, secant is 1 over cosine of x to build our key points and asymptotes. All right, now my phase shift, there's still none. I have no vertical displacement. My vertical stretch is I just have an amplitude of 1 as normal because the 1/2 is no longer out in front of the function. Now it is inside the function, so that's going to affect my period. So that is 2 pi divided by 1/2. So that is 2 pi times 2, which equals 4 pi. Okay, so cosine starts at 1 when x equals 0, but instead of taking 2 pi to cycle through, now it takes 4 pi. Okay, so 1/4 of that to go from a maximum to a 0 is now pi, and it takes me another pi to reach my minimum, and then another pi to get back to 0, and I would have another maximum again at 4 pi. All right, and we'll continue that same pattern over here. And now we have our key points from cosine, so we can use our zeros from cosine to draw vertical asymptotes for secant. Okay, and now my third step is to draw U-shapes, and what was a local maximum becomes a local minimum, and what was a local minimum becomes a local maximum. Number 7 is where we get a little tricky because now we have a phase shift, and I know that that makes it a little bit more difficult for us to think about where all of our points go. Okay, so our phase shift is pi over 2, and remember our transformation is minus c, so since this is a negative, this is a positive, so I am moving to the right. Okay, I do also have a b value, so my period is going to be affected, so it is 2 pi divided by 2, or pi, but I have no vertical displacement, no reflection, and I have no vertical stretch, so my amplitude still just equals 1 like we're used to. Okay, so before we do the phase shift, remember that secant is 1 over cosine, so we're going to be using cosine. So let's just do cosine with a period of pi, okay, and our amplitude of 1. We're going to do cosine. So I'm going to start at 1, but instead of taking 2 pi, I'm going to take 1 pi for my period. So I have to have a minimum halfway there, and I'm going to have zeros here, okay. I'm going to do the couple more on either side here. Alright, so now that would be my original one, okay, but now I have a phase shift and I'm going right, okay, pi over 2. So in this case, I know I was using yellow before for my key points. I'm going to use red because it's a little easier to see. Okay, so I'm going to take every single one of these dots and I'm going to shift it to the right by pi over 2, or 0.5 pi, which is 1 block. Okay, so each one of these goes over 1. Okay, and once you've got the pattern figured out, it becomes a little bit easier to just continue, okay, with those. We would have another one there. Okay, so now the red one is what we're going to use, okay, because the red one is the cosine of 2x minus pi over 2. Okay, so now we're going to use that to draw our vertical asymptotes, and so we're looking at the zeros, okay, for our transformed cosine graph. So every time that's a 0, okay, we have a vertical asymptote. Okay, and now we're going to use, all right, again, our transformed cosine graph, and we're going to use those local minimums to become local maximums, and our local minimums become, our local maximums become local minimums. Number 8 throws the book at us, okay? So starting with A, we have a vertical stretch, so our new amplitude is 1/2. We have B, so our period is 2 pi divided by 2 pi, or 1. And I actually don't have a phase shift, but I do have minus D, so, well, plus D, but a minus 1, so my vertical displacement is -1. Okay, so our parent function way back under there is cosecant, which is 1 over sine, so we're going to be using our sine graph to make our key points. All right, and so again, we're going to start off, all right, with just our parent sine function, okay, which starts at 0, all right, and then our vertical stretch, our amplitude would be 1/2, and I would cycle through with a period of 1. Okay, but now, because I have a vertical displacement, all right, all of my points shift down 1. So what would have been here goes down 1, and so does this. along with every other point that we made that was a key point. So now my vertically displaced sine function goes here, and it would come back up there, down first on this side. Okay, and so now we have a sine function that has zeros now at y equals -1, and maximums and minimums that are above and below that line. So I'm going to use my original zeros, okay, my blue dots that were 0, to make vertical asymptotes. So these ones that are now on this new line of equilibrium if we were in a physics class. All right, and then finally I get to make my U-shapes, okay, and I'm going to use my translated down sine graph for that. And so we end up with this. The last thing we have to do is go from the description of a function to writing its equation. So the first one, number 9, says a cosecant function. So that's going to be in the form of y equals, we may as well start with the whole phone book, cosecant of b, and then x minus c plus d. Okay, so we're going to identify what we have. We have a vertical shift of -4. A vertical shift is d. Our period is 3 pi, so that's going to be 2 pi over b. So when we do our algebra to get back to b, if 3 pi equals 2 pi over b, then b must equal 2/3. Okay? And then we have a phase shift of pi over 3. There's no vertical stretch or amplitude listed, so A doesn't have any value other than its default value of 1. Okay, so now we're just going to plug those in, and we get y equals A is 1, so we don't write it. Cosecant of B, 2/3. X is just there. C, it's always minus that number, so it's minus pi over 3. And then at the end, plus D, which is a -4, and that is our answer. Number 10 is very similar, except now we start out with a secant function. So it's going to be in the form of y equals A secant. All right, B, and then x minus c plus d. We're going to identify what we have. We have a vertical shift of 3 for d, a period of 3 pi. We already did that calculation in number 9, so I know now that that means b equals 2/3, and a phase shift of pi over 2. And that's positive, so c is a positive pi over 2. So when I plug that in, my answer is y equals, A wasn't mentioned, no vertical stretch, so A is 1, we don't write it. Secant, B is 2/3, X stays there. My C is a positive number, so I am subtracting C. And then D at the end, it's a shift of 3, and so that's plus 3.